All right, sorry. What's different about it? The solid liquid interface has a negative slope. There are lots of implications with that. And the negative slope is based off the fact that it's most dense as a liquid, which again is weird. Usually when you cool something off, what happens to the molecules or atoms? They slow down and they get closer together, and that doesn't happen here. Okay, let's draw some arrows. Go with this one. What's the y-axis here? Pressure. And the x-axis? Temp. Alrighty. So I've got, and we're doing water. Okay, so I've got this, something like this going on. And we're looking for a solid here, a liquid here, and a gas here. And what happens when I'm crossing the line in that direction? How about melting? And going the other direction? Freezing. What about this direction? I'm going to go with, even though boiling is, boiling is a specific temperature where vaporization occurs throughout the entire substance. This is just the substance turning into a gas. How about the other direction? Condensation. How about this direction? Sublime. In this direction? Okay, deposition. Alrighty. So, how about what is going on right here? So that is our triple point. All six of those phase changes are occurring simultaneously, as well as all three of the states of matter are occurring simultaneously. How about this spot here? What happens at that critical point? What? Thanks. Can somebody give me a good answer? Obviously, if I increase the temperature of like something that's a gas, it's gonna still be a gas, right? If I'm increasing its temperature, what's happening to the gas particles? They're just moving faster. But what happens if I increase the pressure on a gas? What's that going to do to them? It's going to get them closer together. And if they're close enough together, they might liquefy. But once I've reached the critical point or the critical temperature, is that possible? It's not. So the critical point or the critical temperature is that point in which a substance cannot be liquefied no matter how much I squish it. I could jack the pressure up to 1,000,000 atmospheres. They're just simply moving too fast that when they run into each other, they cannot hold on to each other. All right. So how about this one for water? Most dense when? At 4 degrees Celsius. And then what happens when you raise or lower the temp? Less dense. Very strange. I heat it, it gets less dense. I cool it, it gets less dense.
It's more accurate than experiment.
Yeah. Expansion is just talking about its volume, but since we're not changing the mass of the substance, then its density would be directly related to that. Yeah, it'll get bigger. How about this one about your ears hurting? Pressure increases?
Pressure from the water increases with the air on the other side of the eardrum and lower, causing the eardrums to stretch.
So I've got more pressure on the outside. What's it caused by? I want more. Increased number of what? Just particles. You okay with that? So right now, you have a certain number of particles inside your eardrum and a certain number of particles outside your eardrum, and they're hitting at the same frequency. So if I dive down into a swimming pool, I've got a lot more particles on the outside of my ear than I do on the inside of my ear because the liquid is much more dense. And so those things are now hitting on the outside, and I don't have an equilibrium between the two. So it's all about what side is getting hit more frequently. All right, so in this next question, what is it that we're looking for? We're looking for a volume, right? I'm looking for a volume, and so then I need a unit that has volume, and the only units I have to deal with are liters and millimeters of mercury twice. So I'm going to set a railroad track 12.3 liters. I'm going to do that because that's going to give me an answer in liters. All right, so now I need to modify this, and I need the units that I'm going to put into this next portion to cancel out. So that means I've got millimeters of mercury on the top and millimeters of mercury on the bottom. Okay, so what did I do to this substance, this gas? The pressure increased. So if you increase the pressure on a pocket of gas, what's going to happen to the gas's size? It's going to be compressed. So what I need to do is take my two pressure numbers, my 40 and my 60, and set them into this railroad track to give me a number that's smaller than 12.3. So what do I do with that?
The 40 by the 60?
Yeah, the bigger number goes on the bottom and the smaller number goes on top, and that will give me a smaller number. And so I forget, what is this, like 8 something or other?
8.2.
8.2? 8.20?
Zero, yeah. Can you add that zero?
You have to add that zero.
The same thing.
Yeah, gotcha. Okay. Next thing, we've got a pocket of air, and its temp is 20 degrees Celsius. And now, under a different set of circumstances, it's the same air, but now its volume is only 350 milliliters. And if the only other thing that was allowed to change was temperature, what's the temp going to do? It's going to have to have gone down. It's going to have to have decreased. But before we do anything with this temperature stuff, what do I need to make sure I do? Convert it over to Kelvin. So 273 here, 293 here. Okay. So I need a temperature unit. So I've got 293, and I'm just going to leave that there. And then I need this number to become smaller. So I'm going to write 350 milliliters here and 600 milliliters here. And the milliliters are going to cancel out. And I'm going to get 293 times 350 divided by 600. I get 171 K.
Which converts to
171 minus 273, which converts to 102 degrees Celsius, negative. And there's my answer.
what?
Anybody?
I don't understand. I don't.
Why?
First off, why I don't even
Okay.
understand the principle. If you have 600 milliliters of air,
Uh-huh.
20 degrees Celsius.
Yeah.
Why would the temperature?
Now this same air, you have changed the conditions, and now this air isn't 600 milliliters anymore. It's only 350 milliliters. And the only thing you allowed to change, besides its volume, is the temperature. So what happened to the temperature to get it to shrink?
What is the temperature at 300?
Do I have a bag? So let's see if this thing is filled up with air, and it's at 600. This is 600 milliliters in size.
Okay, I got it.
And so now it's shrunk, and now the bag is only 350
I got
milliliters.
it. I guess I didn't. That question really didn't for me. It didn't visually. I was just.
I'll try to put a picture of where it goes back.
No, it's gonna not do me justice. But no.
Okay. How about my answer? Is anybody upset with my answer?
Yes,
Why?
that's not the answer
What's, what's the answer you got? Something
I got.
171?
No, it was totally different. I got it completely wrong.
So I just didn't convert, but we need to convert in order to get a low enough number. That's right.
I noticed
That's
that
not why.
the milliliters changed by 55%. So I just assumed that you did.
The temperature would change 55%?
Yeah, that's what I said. I love it.
Where is that?
So 600 milliliters, 350 is 55% difference between those two numbers.
Now, what's the difference between 20 degrees Celsius and negative 102 degrees Celsius? Yeah, more than 50%.
Yeah. So it doesn't work that way. It did for the.
Did for the first one?
Yeah, that's how I did percent wise. So obviously.
Well, 55%. Well, it is that for the difference between 171 and 293.
Because you have to convert
But you have to convert to Kelvin to get this to work,
no matter what.
no matter what, under no
That's just
circumstances.
Part of the deal.
So all of these calculations are done in Kelvin, but what was the reason we had to have it in Kelvin?
I don't. You didn't say that.
You can't have a negative number for temperature, because if I have a negative temperature number and I'm converting that over to the volume side, you end up having a negative volume number. Well, what's negative volume? There's no such thing as negative volume. There's also no such thing as zero volume for an actual substance. If it's a substance, it's taking up space. So you have to use Kelvin.
Okay.
Also, a Kelvin change is proportional to the change of the other substance. So you said it's a 55%. My guess is the difference between these two numbers is a 55% change. But not these two numbers. But the Celsius is not what we do the calculation by. That makes sense?
Oh, I see. 293 to 170.
So he's just saying that if you check the difference between 600 and 350, you get about a 55% difference. So if you check the difference between the 171 and the 293, my guess is you're getting a 55% difference. It should be exactly the same. But why did I convert it over into Celsius? That's how it was given. That is incredibly important that's how it was given. I know we're the only country of, I won't say significance, but the largest country certainly that's using the English system. But if you're talking to somebody from, I don't know, maybe Vancouver, British Columbia, about a patient or something, they're going to give you a number, and that number is going to be in the metric system. And if you don't give that number back to them, they're going to be confused, or some bad stuff's going to happen. Someone might say it's a 98 kilogram person, and the person in America is thinking, 98 pound man, that guy's really small, and really it's a 200 plus pound person. So it's not a small person. So whatever somebody gives stuff to you, you have to give it back to them. This is test taking technique, like 101 class. So guess what answer A on a multiple choice test for this would be on a standardized exam? 171. And guess what D is? Negative 102. Yeah. So you might get partial credit for writing this one down, or the exam might not give partial credit. But some of the exams are intelligence exams. By that, they understand that you kind of got near, and so maybe they won't fail you immediately. They'll let you keep working on it for a little while. That's what the NCLEX exam is like. You could be in there for 45 minutes, or you could be in there for 5 hours. Oh, last two questions. What do we got for the names? So that first one is Boyle. And the second one is Charles Law. How about this last one about volatile? Measurement. So when I'm thinking about something like that, we talk about the volatility of fingernail polish remover compared to milk. Fingernail polish remover is way more volatile than milk is, right? I mean, you could smell milk, you get your nose down into the carton, but you don't need to get your nose down into the bottle to smell fingernail polish remover, right? And if I'm sadly inside of a mall and I'm anywhere near a nail salon, I know it. Try to run past that stuff.
Can we answer that? Do we have to? Because I was confused. Is it like normal